Hey everybody, welcome to Supplementary video 21.3 to 20.4. This will be the last video that we have for dual credit, and this one's going to cover a little bit about more about the immune system. So we've already talked about the primary immune response, the innate immune response, which is really helpful because it can generate a quick response, but it's not very efficient. And so if we want an efficient reaction, we have to use what's called the adaptive immune response. The reason it's really helpful, it can create receptors that are going to recognize nearly 100 trillion different pathogens. So pretty much anything that you come into contact with over your life that is foreign, your body can create some sort of memory cell to recognize that if you ever come into contact with that pathogen in the future. And so it happens in two steps here. First, you have the primary adaptive response, which is going to be the first time that you come into contact with that pathogen. The response is really slow. You're going to be relying a lot on that innate immune response. So you're going to have pretty severe symptoms depending on what it is. Now, when I say severe symptoms, maybe you have just a minor cold or something like that. And so by severe, it's not actually that bad, but for a cold, it's as bad as it can get. And again, that response is slow. You're creating the antibodies, you're creating the receptors that are going to be able to recognize that what particular pathogen in the future, so that the second time you come into contact with that pathogen, you get the secondary adaptive response where your body immediately recognizes it and is going to go about destroying it, often before you even realize that you are infected. And so it looks a little something like this here. So you have your initial exposure, you have your primary immune response. Again, it's a small, slow response, but your body hangs on to pieces of that help it recognize that same pathogen in the future, so that the next time you are exposed to it, you can generate a very quick and a very large response. This is how vaccines work, whether they be like the COVID-19 vaccine, where it is an mRNA vaccine, or your typical live or dead virus vaccines. That vaccine is your initial exposure. You get minorly sick generally, because it is in such a low dose. But then if you are ever exposed to it in the future, your body can generate a very large response. Now, it is possible to lose this memory over a period of time, just depending on a number of different factors. So that's where oftentimes, like boosters, like you'll have different boosters when you are just born, when you are turned 2 months old, turned 4 months old, or if you have a virus, for example, that mutates. If that virus mutates, oftentimes it's going to mutate in a way that it is no longer recognizable, based on what your body remembers about it. And so you're going to have to go through this response again. So that's like why you would get the flu vaccine every year. It's mutated it enough to where you need a new vaccine to generate a new initial exposure, so that if you ever come into contact with it, your secondary exposure can be quick. So T cells use what's called alpha beta cell receptors to specify which antigen they're going to be set out for. And so you can see here, this is going to be the membrane. They're going to have this transmembrane protein that they are anchored to. Both the alpha in orange and the beta in purple here have this constant region. So these are proteins here, so a sequence of amino acids that are generally the same between all T cells, but then each T cell is going to have a different variable region, sometimes mostly in the alpha chain, sometimes in the beta chain, sometimes both. But this variable region is what's going to be very specific to the one antigen that they're able to recognize and attack. So you may have a T cell set out for some sort of virus that has a specific antigen on its surface. So this T cell will be able to recognize it because it has this saved alpha and beta chains that is exactly matched up with that viral antigen. So it's going to be able to recognize it very quickly and be able to attack it, because it's only going to bind to that specific pathogen. Okay, so there's a lot more that goes on with the immune response. We talk if we want to talk about memory T cells, effector T cells, looking at different immunoglobulins and things like that. We're not going to get into those really for this class. I could go over them. They do oftentimes show up in in an anatomy class in college, but compared to the time we have and what we're learning so far, I just wanted to give us just a little bit of a taste into the immune system. So if this is something you have more questions on, something you want to learn about more, you can talk to me. The textbook has everything that you will need to reference, so you also have that resource as well. So just make sure you're asking questions.